Right, good morning everyone. Ready to kick off? I'm Dirk Lennox, Chief Executive of CIRIA. Welcome to our first 60th anniversary series webinar on beach management. And before I make a further introduction to CIRIA and what we're going to discuss today, I just want to cover a few housekeeping points. As you will have noticed, we are going to be recording. The listeners are in listen-only mode. If you've got any problems with your connection or audio, just drop us a message in the chat box Q&A, and one of the CIRIA team will help as much as they can. We've reserved plenty of time for questions at the end of the presentations. If you have a question as you see the presenters and the slides in front of you, just type in the question, and the chair for the day will moderate and assign the question to who's going to answer. But do let us know if you've got a particular speaker that you would like to put a question to. Please share your views and experiences. As you can see, at CIRIA Updates, hashtag coastal engineering, hashtag beach management are there to disseminate and spread the word. We've got a fantastic turnout, 100 registrations, a great variety of CIRIA members from the Environment Agency, Network Rail, all the way through to consulting members like Atkins, Motts, Coe, John Grimes. We're delighted to have everyone on board today to celebrate CIRIA's 60th anniversary that we have been celebrating throughout the year. For those who are not familiar with CIRIA, we were initiated 60 years ago coming out of the ICE, and since then have delivered 1,000 projects or more, and a number of fantastic legacy projects, and this is one of them. Originally, the first edition came out in 1996, and then in 2010 we had this second edition, which is still selling well and still being used widely by the profession. And I'm really delighted that today we have a stellar cast to talk you through the guidance and to highlight the salient points that are still relevant to today's practice. And to help us go through this and navigate through the session, we've got a great chair. It's my pleasure to introduce you to Jonathan Rogers, Sales Operation Manager at Jacobs. He works for the infrastructure and urban planning in the Middle East, coordinating all the major bids in that region. This builds on his previous role covering clients across Europe and the UK. Prior to this, he was also working for CH2M, Halcro, one of our CIRIA members from the past. His 27-year postgraduate technical experience includes developing the Beach Management Manual, the National Coastal Erosion Risk Mapping Project, various strategies, SMPs, and the design of the Pevensey Bay Sea Defence PFI scheme, which we'll talk about later. So it's my pleasure to introduce you to Jonathan Rogers. Over to Jonathan.
Thank you, Dirk, and hopefully you can all hear me. Right, hello everyone, and welcome to today's webinar, which, as Dirk has just said, is part of a series of webinars CIRIA's seminal publications as they mark their 60th anniversary. Today's session looks at the second edition of the Beach Management Manual, which was published in 2010, for which I had the pleasure of being the lead author and overall editor. Here's the agenda for today. I'm going to give a very brief introduction of how we got here. Then we'll hear from Alan Frampton and Carl Green regarding beach management from south and northwest perspectives respectively. That'll be followed by two case studies, the first from Ian Thomas looking at Pevensey Bay, and the second from Andrew Rouse looking at Linkshore. After that, we'll have a bit of a discussion and Q&A, so get your questions in, and finally we'll wrap up just in time for you to go and get some lunch. So, beach management. Very brief introduction here. Beach management can be defined as all or any of the activities concerned with the controlling, using or improving beaches for defence, recreation or other purposes. 1996 saw the first edition of the Beach Management Manual, which provided some excellent guidance for the management of beaches for coastal defence purposes. Since then, our approach changed dramatically with our need to consider the wider environment, including amenity and ecology. Furthermore, our approaches to monitoring and maintenance developed rapidly. Beach management design and execution also evolved, and all this progress led to the instigation of a scoping study in 2007, in which we examined how the manual could or should be updated. Following extensive consultation during the scoping study, we arrived at a way forward, ultimately the development of the second edition of the Beach Management Manual, which was published in 2010. And I do have a copy here, all 915 pages of it. Now, the manual had some clearly stated aims. It was to provide authoritative guidance on managing beaches for coastal defence purposes, and also to consider other drivers such as the environment and amenity. And it also included state-of-the-art methods, guidance and information on beach monitoring and maintenance, and also case studies specifically examining all aspects of beach management. Now, to achieve this, we needed a truly collaborative effort, both by the funders and the steering group, and particularly by the research consortium, who came together to share their wide industry knowledge. The organisations shown here are those at the time of publication, although several have now undergone various changes of entity. At this point, I'd also like to pay a bit of tribute to those on both the steering group and also the consortium, who are sadly no longer with us. The Beach Management Manual was a small part of their wider legacies. So the aim of today's webinar. Today we'll hear various industry experts outlining beach management policy, planning and strategy. They'll be sharing new tools and techniques, beach management, including practical applications and good practice. And they'll also be covering a couple case studies illustrating beach improvement schemes and sharing data and experiences. So today I'm delighted to be joined by Alan Frampton, who's the Strategy and Policy Manager at Bournemouth, Christchurch and Poole Council, Carl Green, from the Head of Engineering Services at Wyre Council, Ian Thomas, Project Manager at Pevensey Coastal Defence, and also Andrew Rouse, who's Project Team Leader of the Environment Agency in Anglia region. So moving on, first up, I have the pleasure of handing over to one of my former colleagues, Alan Frampton from Bournemouth, Christchurch and Poole Council, who will give you an overview of beach management from a South Coast perspective. This will be followed by Carl Green from Wyre Council, doing likewise from a North West perspective. I'll give you a little bit of an intro to both of them now up front. So Alan is BCP's Council's Strategy and Policy Manager for Flood and Coastal Erosion Risk Management, a post he's held since August 2019. Alan leads a team of specialists to deliver a range of activities as part of the Council's dedicated FSM service, including beach management plans, coastal monitoring and R&D. Delivering these activities draws upon Alan's previous experience working for Jacobs, where his work included contributing chapters to the Beach Management Manual. Carl is a member of the ICE with over 30 years experience in design, construction and operation of coastal defences, working for consultants and the Environment Agency on the East Coast before returning home to the Northwest in his current role as Head of Engineering at Wyre Council, where he's responsible for the delivery of coastal schemes, their ongoing operations and maintenance. But firstly, Alan, over to you.
Thanks, Jonathan. Just waiting for control of the slides. Hi everyone. Yeah, pleased to be able to give a bit of a South Coast perspective on beach management, particularly drawing on the experience of beach management in the Poole and Christchurch Bays area, which is located on the central south coast of England between the Isle of Purbeck and the Isle of Wight in the east. Just a bit of context and background. We have numerous sites in the two bays where there's a history of beach management being a key component of the coast protection measures for the coast. You can see the various sites highlighted on the map here. The base map is actually the shoreline management plan policies adopted in 2011 for the next 100 years. And a key assumption within the shoreline management plan is that the approach of beach management will be continuing to be the primary form of defence for the foreseeable future. So you can see it's quite an important aspect for these two bays. In the western half of the area, Poole Bay and Swanage, that approach to ongoing beach management as being the preferred approach was confirmed in the 2014 strategy that was approved by the Environment Agency, and it will be one of the key options that will be appraised in the Christchurch Bay and Harbour strategy that we're currently in the process of developing, working closely with New Forest District Council and the Environment Agency. I'm going to focus mainly on the largest scheme we have ongoing in our patch at the moment, which is the Poole Bay Beach Management Scheme, which stretches from sandbanks at the entrance to Poole Harbour in the west to Hengstbury Head and the Long Groin in the east at the boundary between Poole and Christchurch Bays. And the image on the right of this slide is just an aerial view looking back towards the sandbanks part of the frontage. So this area has had a long history of coastal protection measures being installed over the last century or more. Seawalls have been constructed in various phases, gradually extending the length of seawall to prevent erosion of the backing cliffs. That has generally worked. We do have still some stability issues, but it has also served to cut off the natural supply of sediment to the beach. Groin fields were subsequently added in the past, including in the late 30s the construction of the Hengstbury Head Long Groin at the eastern end of the bay, which is now a critical control on the evolution of the two bays themselves. And since the 1970s, we have had artificially widened beach, which is when the renourishment of the frontage began, and we've had various campaigns over the decades since then. So the Poole Bay Beach Management Scheme, the current round of works is a 10-year programme that was achieved £33 million grant and aid funding in May 2020, and there's a £3 million contribution from BCP Council towards that. And that total of 36 million is going to replace 26 of the timber groins along the frontage in the next 10 years, allow 2 beach renourishment campaigns to be undertaken, and it's going to see the repair and upgrade of the Hengstbury Head Long Groin, which is the structure at the bottom of the image on this slide. In terms of the timber groin renewal programme, the current phase of works is a 2-year contract being delivered by Suttles. We completed the first part of that contract last winter spring when we took out 5 timber groins and put in 4 new ones. We're about to start on site. We're taking out a further 3 and putting in 4 new ones. You can see from the image on the bottom left of this slide the scale of the groins that we're talking about, and we try to recycle as much timber as we can from the removed groins back into the new ones when they're constructed. In terms of beach renourishment, the first of the 2 campaigns in the funded programme that we're currently working in occurred in spring this year, when we placed 350,000 cubic metres of sand ashore at a number of locations along the frontage where we had depleted beach levels. We have extensive monitoring records, and we typically lose around 70,000 cubic metres of sediment from the shoreline every year. So this will give us about 5 years before we need to do the second renourishment that's part of the current scheme plan. So a key challenge for us going forward is the continuing supply of the volume and quality and grading of sediment that we need to undertake that beach renourishment that we want to place, and we have marine licence conditions requiring us to fulfil in terms of sediment grading. Historically, the sediment source for these renourishment campaigns has come from licence dredged areas around the Isle of Wight, such as those marked on the map here. But this year, for the first time in history, we had to go further afield into the southern North Sea to obtain the sand and sediment that we were after for this work. And that poses a number of challenges for us going forward, including how do we cover the increased construction costs? We have an increased risk of weather delays. It's a 30-hour round trip compared to less than 12 hours from the Isle of Wight. And obviously that then in turn incurs a greater carbon footprint of this operation than was anticipated, which is not ideal in a time when we're all trying to reduce the carbon impact of our operations. We also have a number of other questions and challenges longer term that we need to think about, including the sustainability of timber supply for future timber groin replacements. The dimensions of the seawall and groins that we currently have along the frontage need to be looked at further. We currently fill the beach up with renourishment to the maximum we can, up to the top of the seawall level. So if we wanted to widen or raise or increase the size of the beach to counter the effects of climate change, we have to fundamentally rethink what those the geometry of the bay looks like. And we have an increasing issue with wind-blown sand, which covers large areas of the promenade at times and is an increasing maintenance cost for our seafront operations team. So overall, with all these challenges we're facing, it does beg the question of how sustainable the current approach to beach management in this area and the other areas within the two bays is, and what are options for the longer term. And that those longer term options will be something we'll need to consider when we eventually come to review and update the 2014 strategy for this frontage. And at that time, I would expect that we would look at a range of options, including those listed here. If we looked at do nothing and returning the coast to a natural state, that would restore the natural sediment supply from reactivating cliff erosion to the bay, but it would mean relocating many thousands of property and infrastructure. The current business case is based on protecting over 6,000 properties over the next 100 years, so you can get a sense of the scale of relocation that would be needed if that was ever to be taken forward. We could consider going back to a course of sediment grading, which would allow us to return to some of the dredged areas around the Isle of Wight. The current grading obviously gives us a nice wide, many miles of sandy beach, which is vital and a key selling point in terms of the amenity and tourism offer of the frontage. So that would be a bit of a challenge to sell. We could investigate if there are new areas of seabed to provide sediment sources in the future. We could fundamentally change the coast protection approach. If our key aim is to protect 6,000 plus properties, we could look at moving to a more hard engineered system with larger seawalls, maybe rock revetments, etc. And that's actually something floated in the shoreline management plan as a possible option to move towards in the very long term. And it's one of the few places around the country where the S&P policy suggests that we might look at advanced align longer term. In terms of the groins, we could look at going from timber to rock groins along more of the frontage. The sandbanks end of the bay already has rock groins installed, and so we could maybe look at using rock groins in other parts of the bay. And in terms of sand dunes, in the late 90s, early 2000s, at sandbanks as part of a coast protection scheme, an area of artificial sand dune was created, and we've recently undertaken a review of that work using some funding from the SCOPAC research programme to assess the performance of the dunes over the last 20 years, and that's actually proved that they are both functioning reasonably well, and there's evidence of the dunes looking to naturally grow and spread eastwards from where they were created, just purely due to wind-blown seeding. So in order to get ourselves ready for the future, we're doing a number of things already. So back in 2016, my predecessors at the councils that predated the formation of Bournemouth Christchurch Pool Council, along with colleagues in Purbeck in New Forest in the Environment Agency and Channel Coastal Observatory, recognising that the supply of sediment long term would become an issue, albeit not necessarily as soon as we've now experienced this year, gains funding to undertake investigations to improve the understanding of sediment transport in the bays. And that funding deployed a number of AWAC devices to provide calibration and validation data to a new sediment transport model that was developed by HR Wallingford. And that model has improved the understanding of sediment transport both along the shorelines and within the bays. And what we're doing with that information now is taking it on board and evolving it into something we're calling the Dalston to Hurst Sediment Resource Management Programme. And that is looking at how we can coordinate and manage sediment along the shoreline across all the beach management sites in a more joined up, coordinated way, and possibly look with the aim of maybe looking at how we might provide efficiencies longer term by coordinating on renourishment campaigns, for example. Underpinning that approach is the ongoing monitoring. So we have good records along much of our frontage, and certainly since 2002, when the South East Regional Coastal Monitoring Programme commenced, we have continual data along our beach management sites that helps us make decisions. And in places we supplement that with survey data captured by our in-house team. And one of the things we're planning to do in the near future is some further study using that monitoring data and other information to review and update our trigger levels for beach management, both considering the present conditions, but also what the beach might need to look like in the future in the face of climate change. And to bring all that information and knowledge about how we manage the beach together, what we're doing for the Sandbanks to Hengistbury Head section is developing a new beach management plan in line with the CIRIA guidance for this. That is going to set out for each part of the frontage our approach and rationale for management, the new trigger levels when we develop them. And it's also serving to bring together into a single resource the information that was previously contained in files in two separate authorities that manage the frontage at Borough of Poole and Bournemouth that have now been combined as part of the BCP Council. So just by way of summary, this diagram sets out all the key elements of the framework we operate coastal risk management under within our area. So we start with the shoreline management plan, our strategies, our schemes, and you can see the beach management plans and our beach management approach is a key component of that framework. And last slide from me, if you'd like to find some more information about what we do at BCP Council and in the Two Bays area, there's a number of links here that you might find of interest. Thank you.
Okay, thank you.
Okay, Carl, over to you.
Okay, thank you very much, Jonathan. So my name's Carl Green. I'm head of engineering at Wyre. I'm also chair of the coastal group on the northwest coast. Hopefully we can do this. Okay, that's me. So I'm just going to give you a quick overview of the northwest. Okay, so I'll give you an introduction of the northwest coast. Some of the programs or schemes that have happened in the past, how this fits in with the framework of the SMP strategies and business cases, and then I'll just have a look at our regional monitoring program that Alan's just mentioned before, and how that helps us to shape the future of our coastline. And then I'll go through an example and the Rouse Coast Defence scheme. So it's going to be quite a rapid run through. So this is the northwest coast. So it runs from Great Orme's Head in the south up to the Scottish borders in the north, and it forms part of the Shoreline Management Plan 22. So each of the coast is split into 11 cells, and our Shoreline Management Plan 22 covers the whole of the cell 11. So looking at some of the schemes we've done in the past, so this is Morecambe, and this was one of the first ones. It embraced the beach and brought the town in with the beach, and had built quite large fishtail groins to promote that beach and bring people along with that, and using artwork as well. Then we have Blackpool, which tried to bring the town to the beach and celebrate that linkage between the beach, using those hard defences, but also celebrating that beach. The Blackpool beach disappears at high tide and then comes back. So it's good for Blackpool because it forces the tourists to go into the town. This is Cleveleys, which brought the town again, linked the town to the beach. So what we tried very hard to do was link the town and the beach, and so there was always a barrier between the beach area and the town, which was created by the big seawall, and we tried to link the two together. And the last one was Lytham, which was completed and opened this year. And again, this is more of a green beach because it's on the edge of an estuary, but it's a headland scheme which tries to, without that headland, you could potentially have a significant amount of scour when you can see the properties behind, which would be lost if we didn't maintain that headland. So all the plans are linked to the shoreline management plan, which is non-statutory, but it follows that guidance, and it gives us that view for the future. So we've been through the whole range of scenarios with the shoreline management plan, and we're left with a number of areas which hold the line, but other areas which are no active intervention. And we're currently going through the refresh of the shoreline management plan to make clearer what those intentions are going to be, both to planners and to managers in the future. Our shoreline management plan is about 15 years old now, so we're coming towards that second epoch phase quite quickly, and there's a number of areas and decisions we need to make, and beach management forms a really important part of that. So from the shoreline management plan, we then moved into the strategy plan, and this I'll concentrate now on my particular area, which is Wyre, and this is a headland area. What we tried to do in the strategy was to have a 100-year life of the strategy, but to look at how we might maintain a 200-year standard across the whole of the frontage. That's both the estuary side of the area, in this side of the area, and then the open coast, the western side of the area. And what we tend to have here is we've got the movement from south to north, and there's a spit forming at the end, and there's a loon deep, so we get a circulation pattern in this area. So the big problem for us on the northwest coast, along a lot of areas, and particularly in this area, is we're very susceptible to flooding from the sea. We have flooding in years that end in 7, it seems. So we had flooding in 27, 77, and so our next one is back to 27 again. But significant flooding, over 4,000 properties flooded within this area, a number of deaths in the 27 event. But we've been building defences and hard structures to protect that, but the beach is the most important part of that issue. So this is our main problem, is that these defences, hard defences, it's a very erosive environment, and we're losing the beach in front of them, and that's exposing the defences, and this is where we get breaches, especially because these beaches are very variable. So we're losing 2 to 3 meters of beach during a storm event, and the whole point of what we're trying to do within the strategy is to try and reduce that variability, so we don't get that scour, and we don't have that secondary storm which would cause significant problems, but we do get an awful lot of overtopping. So the Wyre Dune and Beach Management Scheme was put together a couple of years ago. So it protects over 11,000 properties and has a total benefit of £434 million. The scheme value is about 42.6 million. So significant amount of scheme. It's we looked at the best way of doing that, and this is only a 20-year life of this scheme. So we're looking at climate change for the next 20 years, but beyond that we need to look at different solutions, and that may be bringing in beach nourishment. But at this present time, what we're looking at is a beach management scheme which is around harder structures. So we looked at a number of different options, whether we could increase the permeability of the revetment so we get less reflection, whether we enhance the timber groins. Now, the problem that we've had with our timber groins is it's such an aggressive environment that the timber groins get damaged on a regular basis, so we're constantly maintaining them. But once you get a panel lost from those timber groins, it actually makes it worse, because you encourage a scour channel at that point, and then that energy comes there. We have had a look at precast concrete steps to try and again to increase the revetment reflection, or reduce that reflection, so we get the offshore movement. We did look at beach nourishment, and we did look at sand engines. The issue with that is this is a very flat open bay, and to get the necessary dredges and various things in place was very difficult. So the option we've gone for is a rock armour groin solution. You probably can just about make out the idea, but the idea is a number of headlands along the coast which will trap the sediment within them, and you can see on the bottom right here the overall solution and the idea that these are approximately 100 meters long, about 100-meter bays. So these are headlands the whole idea is to try and trap material in this upper beach area where it has the greatest effect, but allow natural sediment to move along the coast, so we're not starving areas of the beach further along. So in terms of our research and monitoring campaign, we too have a regional monitoring strategy that's been going around 14 years of data now we've collected, and the phase 3 has now started again. So this involves lots of topographic beach profiles, dune tows, wave and IWACS, and LiDAR, and a number of drone surveys. And we've invested in that sort of technology within the northwest coast, led from Sefton, but a number of my guys at Wyre are part of that team and constantly monitor the coastline. The other thing that we've tried to do on our section of coast, and we're looking to develop along the whole of the coastline, is a radar system. Now, the radar system gives us a better visual view of what's occurring on the coastline. It's been, you can see the system here. It's basically a ship's radar, but it monitors the wave patterns and links those across, so you can work out bathymetry from it, currents and flow movements, and we can click onto a couple of these. It just gives us a real understanding of what's happening during storms, which is for me potentially more important than that long-term data. We're getting that long-term spatial data over the 16 years, which demonstrates we're losing about 50,000 cubic meters off this frontage, which we'll need to replace. But it's that drawdown during storm events which we're particularly worried about, because that's where we get our breaches. So you can probably just make out on this the patterns on this slide here of the sediment moving along the foreshore. So that's and we can develop this over a number of tides and combine radar systems so that we get that movement along the whole of the frontage. So these are the 3 radars that we've apportioned in Wyre. So we've got one down at the Cleveleys area, one at the Rossall area, and we've got a mobile system currently on the north frontage. So we can, because we get the overlap in these areas, we can follow the sediment movement along the whole frontage. And by linking these up with the LiDAR and satellite images, we get a comprehensive view of what's occurring over the beach. And that's the next step, is to have a synopsis of these different technologies, which you can move over a time period, and we're working on that at the moment. So I'll quickly go through the Rossall Coast Defence Scheme. Now, this is a scheme which completed last year, and it's been really successful, but not just because it's created higher beaches, but because of the way the public have embraced what we've done. So a lot of this has been accessibility to the beach. So you can see the properties behind. Now, this seawall is approximately 1 meter higher than the rooftops of those properties, so it's quite a low-lying area. But what we have managed to do is create rock groins in these headlands, which we're looking at the major beach strategy, together with a rock revetment, which has prevented that reflective movement offshore. The rock groins as well are significantly better in terms of maintenance, so we're not constantly going back to maintain these areas. So we're gaining sustainability in that respect, although there is a carbon impact, obviously, of bringing these large 8 to 10 ton rocks onto the foreshore. The other things that are of note are crossing over how you gain access across these major rock groins, because we need to maintain that safety access. So you can see along here we've spent a lot of money in steps up the access ramps, and also crossover groins. You can just about make them out here, and those are significant structures which we're looking to try and optimize in the next scheme. So if anybody's got any ideas of how to do that. This section here is an outfall from the United Utilities, and we had to bridge that. That was a significant amount of money, approximately £3 million on that section. All this area, this is all precast concrete works, and we brought in in total about 500,000 tons of rock to this frontage. But it has been really successful. That's the next one. Okay. So in terms of the Rossall scheme, the scheme was about 65 million, but we spent some money on developing the radar systems, and you can what we're interested in here is what's happening between the groin structures. Now, what we're trying to do, and what we've been successful in doing, is creating very stable areas here, which has given us confidence that we didn't need to do some initial nourishment on those beaches. We're not getting drawdown during tidal events, during storm events, and we were able to defer the £2.25 million worth of nourishment works which were planned for that area, and we haven't had to do that because the headlands are full and raised about 2 meters in total. The other things that we have been trying to do is educate the public around the beaches, because it's become, in the initial address, it was become so much more important about the wider environment and the amenity value of these beaches. So we're involved with a number of citizen science projects to try and bring the public along with us and to get them to understand the importance of the beaches in terms of energy distribution, but also for the fantastic use that you can make of those beaches for activities. Our latest one is part of the innovation project, which you can see here, which is the Eco Cobs, which is environmental community owned buffer strips. And the idea of that is to buy some time along some of the frontages where we can't put harder solutions and expensive solutions in place, but we want to buy some time so that people can adapt and communities can adapt to the foreshore. But I can go on to that a little bit later. So this is all around building a community, and we've done that, and we've engaged with these community groups, and we've created what's known as a Coast Watchers, which we're hoping to roll out along the whole of the northwest coast as part of the Eco Cobs project. So that's me, and so we've constructed these beach management schemes under a strategic framework. The monitoring has allowed us to reduce the initial capital investment, and we're getting some really good results back, and on how reducing that risk of intervention. So we're saving money on that, but also when you should intervene and when you shouldn't. So we're creating these triggers, and really just for beaches are far more than just protecting from flood and coastal erosion. They are part of the place, and the place setting is everything within this context. So thank you very much for listening.
Okay, thank you, Alan and Carl. That was excellent, really good. Okay, we'll now be hearing from another one of my ex-colleagues, Ian Thomas, who will be presenting a case study on the Pevensey Bay Sea Defences. Ian is a land surveying graduate who has worked in a variety of roles across the broad spectrum of mainstream civil engineering in the UK and the Middle East. Since returning to the UK in 1999, he spent 21 years as the project manager of the Pevensey Bay Sea Defence's PPP scheme. Working with the Environment Agency, the project has been seen to develop best practice for maintenance of mixed shingle beaches. Ian, the virtual floor is now yours.
Thank you, Jonathan. Good morning, everybody. Right, got there eventually. Good morning, everyone. I'm going to give you a brief history of what we've done under the Pevensey Bay scheme. For those of you who don't know, Pevensey Bay is on the East Sussex scheme. For those of you who don't know, Pevensey Bay is on the coast midway between Eastbourne and Bexhill. We manage 9 kilometres of shingle embankment, and we're right at the start of sediment subcell 4C. There's quite a delay on the slides at the moment, so I apologise. In the west of our area, right on the edge of Eastbourne, we have Sovereign Harbour. Sovereign Harbour is a totally non-natural harbour, and it now has over 4,000 homes. The harbour arms, here you can see at the bottom of the slide, prevent any natural feed of material from Eastbourne into Pevensey Bay. And the arms themselves also have created a scour feature immediately downdrift of the marina. Moving further east, we come into the Pevensey Bay section, where we start to get some discontinuities in the alignment where properties have been built, probably in inappropriate locations. When you come into the heart of the village, the area the Victorians built, they were stupid. They built the houses at the back of the beach and not on the top of the beach. We also have to we have several outfalls that drain the hinterland through. Continuing onwards, we come to the area we call beachlands. These properties here were built in the 1930s, but they were never intended to be lived in. They were upmarket beach huts. But after World War II and the start of the baby boom period, then these were bought up and people converted them into houses, and they're right on top of the beach. The thing to really notice here is at the top of the slide, you can see the alignment here. This is the area that the tide line the sea would naturally like to have. And if you follow that line down, it's coming right through all of those houses. Moving on to Norman's Bay. Norman's Bay is very similar in that, again, you can see the line the sea would like to have, and these houses are right in the way. And finally, looking back from Couden at the extreme eastern end of our frontage, we're now into an area of very low clay cliffs. We have some more outfalls that are draining the land behind, and our terminal groin is here, just at the edge of Couden, which we use as a main recycling point. Pevensey's no different to most of the south coast. It's no longer self-sustaining. There is little feed of gravel from the channel. As sea levels have risen over the millennia, the sediment that was coming freely in from the channel and forming the beaches is no longer doing so. The chalk cliffs along a lot of the Sussex coast now are being protected. So if you're in the East Brighton area, you'll find that most of the cliffs now have promenades along the bottom. So there is no no cliff recession, no shingle coming from those cliffs and being added to the system. So we're now in a position where littoral drift exceeds the natural supply, and there is a net erosion. In the terms of Pevensey, we've also got these three things at the bottom to consider: Sovereign Harbour, Eastbourne, and underinvestment. Sovereign Harbour was built in 1993. It's totally non-natural harbour, so to allow vessels access to the marina at all states of the tide, the access channel has been dredged 2 meters below seabed level. So consequently, no sediment that comes from the Eastbourne area will go past the marina and on to Pevensey Bay. Further to the west, Eastbourne in the 1980s and 1990s, the sea defences there fell apart, and all the shingle that was in Eastbourne migrated towards Pevensey Bay. Then the harbour was built in 93, that stopped sediment, and then between 1997 and 1999 there was a major capital scheme at Eastbourne with 94 major groins constructed, a capital recharge, but most of the filling was done in the western end, and the eastern end was underfilled. So consequently, in the first 5 or 6 years of the scheme, no shingle was going past Langley Outfall, which starved the downdrift areas. At the same time, Pevensey had gained all of that material from Eastbourne over the years, but then Pevensey's groin field started to fall apart. The Environment Agency had less and less money with which to maintain the frontage, and consequently the groins just got worse and worse. And it was under these conditions that the government said to the agency, please consider a PFI type contract. PFI type contract is where the private sector tenders to provide a service, in this case provide a sea defence. They're contracted typically for 15 to 30 years. Whoever does the job will fund, design, construct and maintain the asset, and for that they will be paid an agreed periodic sum. That sum will vary year on year in terms of inflation, but in real terms it will remain the same. In our case, we took a 25-year contract that started in 2000, and the aim of our scheme is to prevent against breach for up to a 1 in 400 year storm. To provide that standard of defence, we needed to put in place what are known as key physical features, and that meant improving the original condition of the beach that we inherited. On top of that, we have to provide emergency response. So regardless of what type of storm we're going to get, we still have to provide emergency response. We always have to be mindful of the environment. We're trying to conserve what is there and work with nature. And the risks that were associated with the work were identified and shared, and I'll talk about that in a couple of slides' time. So the service definition, the level of protection is 1 in 400, as I said. So for that, you need to define a storm and the range of storms, and the storms consists of the tide, the astronomical tide, the storm surge, and the wave height and the direction that occur at the time of high tide. The project had a full joint return probability analysis done, where all events from 1 in 1 up to 1 in 400 were all classified. Why was that done? Well, the contract also included an element allowing for increased storminess. Every 10 years we could review what had happened by looking at all the events and see if there'd been an increase or conversely a decrease in storminess. An increase would have meant more money for the contractor, a decrease would potentially mean handing money back. The contract also considered sea level rise. We were told to expect 6 millimetres per year. In reality, in all the reviews that have been done so far, we have seen that there's just over 3 millimetres per year along this stretch of coast. Why was model data used? Well, we possibly could have used real-time data, but it was always felt that if you were relying on a wave buoy out in the channel and your 1 in 400 year storm came along and the wave buoy disappeared off towards Belgium, then it wasn't going to be a great deal of use. So consequently, everything is done on model data. There's a rough description of the key physical features. The key contour really is the rear 5 metre contour, because the rear contour then defines where the front 5 metre contour has to go. We have 53 sections through the beach that are monitored, from which we can derive overall volumes. All volumes are measured above 0 metres ordnance datum. And we have something like 2 million cubic metres that are measured as the overall defence. Of course, the beach changes every high tide, so we have to have some tolerances. We have an overall tolerance of -2%, so that's 40,000 cubic metres only that the beach can reduce by. And the crest can only move back 5 metres before we have to take reinstatement action. And some of those risks I was talking about, as the contractor, we proposed a design that, although it was accepted by the client, it's still our risk that it works. We have to provide all the materials and whatever machine costs that are involved, and we carry the risk of all shingle lost for up to a 1 in 50-year storm. There were some shared risks. The primary one initially was the statutory approval, so that if the environmental statement hadn't been issued, then the project would not have gone ahead. And we share the risk for shingle loss storms between 1 in 50 and 1 in 400. As the client, the Environment Agency has their own set of risks. Any instructions they choose to give us, any changes in the law, any outside work impacts. For instance, if things change dramatically at Eastbourne, updrift of our area that changed the way the beach behaved, then that would be an agency risk. And of course, everything that happens in a storm greater than 1 in 400 years. That's better. So our management strategy, we had to raise the minimum standard of defence. In some places, the defence has got as low as 1 in 20 against breach. That was carried out by importing around 200,000 cubic metres of shingle and building some new structures and reinforcing some others. Once the defences were improved, we're then basically into the maintenance period. We still require an annual recharge of around 20,000 cubic metres. We do regular recycling, reprofiling and bypassing, and as the groins fail, the beach is gradually returned to more of an open beach rather than a fully groined beach. And as I said before, we provide emergency response, so we have to have a 24/7 duty officer cover, and we have to mobilise whatever plant is necessary during those storm events. Those are the 4 different techniques we employ, but the key element of all those is monitoring. We do a full beach survey every month and build a 3D model of the beach, and it's from that modelling that we can work out what we need to do. Has there been 5 metre crest recession? Yes or no? How are we going to repair it? Are we going to do it by reprofiling, or do we need to do recycling? Has the volume fallen by more than 2%? Yes. Therefore, we need an annual replenishment. How much do we need to bring in? So the monitoring and regular monitoring is the key thing. We look at them in order, bypassing. So the sediment that now does arrive from Eastbourne arrives at the south side of Sovereign Harbour, has to be taken off the beach. We only have one locator that can do that. It's loaded into road lorries. The road lorries then drive round a route that is fixed by Eastbourne Borough Council. We can't divert from that route. We have to drive onto the beach, and we have to tip it on the north side of the harbour. So there's not a lot we can do with that, other than, is it not possible that we can actually try and move shingle around more sustainably? Is it possible to install a pipeline below the marina and then pump it across? Is it possible to load sediment onto barges and move it by sea? These are things we've thought of, but they're very expensive, so they're not the sort of thing that we as contractors can take. But I think it's something that we, as a coastal community, should be thinking about. Annual replenishment or renourishment, we've changed that significantly. Typically, sediment would be pumped on the beach, recovered, stockpiled on the top of the beach, then dozed into place, graded, and then surveyed for measurement purposes. We decided that wasn't a sensible thing to do. We were confident that the material we get on the beach only moves longshore, it doesn't go cross shore, so it's not lost. So what you see in these 4 pictures is the build-up of 20,000 cubic metres of shingle being delivered to the beach over a 2-week period. So that by the time we get to this bottom right-hand corner, that's 20,000 cubic metres, and then we've left it. And over the next 12 weeks, you can see that that distributes itself really quite nicely. Even after 2 weeks, you can see that the shingle's starting to move. After 5 weeks, it's definitely on the move, and you've got much more of a beach shape, and sediment is going up against the rocks. After 9 weeks, it's now looking very much like a beach. And after 12 weeks, you can actually see that substantial amounts of that material have already started moving along the coast. So in doing that, we reckon we've saved ourselves about 15% of what the costs were for our renourishment compared to a system where we had lots of machines on the beach and all of that kind of carry on. So we don't do that anymore. Reprofiling or beach bumping. This is a curious one in that I personally don't really believe it's necessary. The purple line and the green line pretty much represent the same volume. Is there any purpose in moving these storm burns and pushing them back up to the top of the beach? Are the waves not going to do that for you if you get a storm anyway? That's the kind of view that I have. But conversely, I've got residents who are encouraged by the fact they're woken up by a bulldozer at 6 o'clock in the morning, because to them it means that somebody's doing something to help them. So it does have a political benefit, but whether it has a coastal benefit is another matter. But the main changes really that we've seen in the last 20 years have been recycling. As I said earlier, the surveys used identify where we're losing material and where that material temporarily accretes. So if you can actually mobilize machines in the short term, you don't have to move it very far to put it back again. And the nature of our beach means that we've got up to 10 locations that we have erosion. Therefore, we've got up to 10 locations we need to find material in sinks to bring it back again. And that's where the surveys come in. They show us not only where the erosion is and how much the erosion is, but how much accretion we've got, therefore what distances we need to move it back, and therefore exactly what plant is required to do that. And as I said, the recycling has evolved. We now specifically time our work to start just ahead of a spring tide, so that the machines are in place. They're doing the last of the reinstatement just before the spring tide arrives, just in case the weather changes, as it's liable to do in the middle of winter. And if we do get then a storm on the spring tide, the machines are already in place to do any repairs straight away. At that time of the tidal cycle, low water is at 7 o'clock in the morning, which is an ideal time for loading dump trucks because you've got access to the whole beach. We do not do fixed price contracts. We hire the plant directly because that means we can just get them in and start work. If you're going to go for a fixed price, somebody's got to come and visit the beach, see where the material is, work out a price. We can just go ahead and do it. If we're hiring machines, we can add and remove items to suit what work is necessary. And much in the same as the contract, allocation of risk. I know the beach better than anyone else. I'll take the risk that I can get the machines working as most efficiently as they can. And sometimes we have to do that. We get areas that are washed out. So just before the machines get washed out, we'll move them up the coast. They'll go and do something else. When the tide drops off, they'll drop back and do the original job that they were intended to do. So we keep them working. And basically, they were actually providing a better service because we're then taking account of everything that needs doing as it happens. Very occasionally, we will try and move shingle along the beach the full 9 kilometres. When we do that, we've learned that we have to do it in convoy. In that way, we can control the speed because it's a lot of houses on the beach. We have a 10 mile an hour speed limit maximum anywhere. As long as that lead truck behaves itself, the others can just follow. And it minimises public disruption with everything happening all at once. This is just to illustrate how things have changed. 20 years ago, 60% of our costs would be on reprofiling or beach bumping, and only 40% would be in recycling. That's now flipped considerably, that we only spent 15% of our costs with bulldozers and 85% of the cost moving shingle around the beach. And as I showed on the previous slide, the fact that we deliberately bring machines in just before spring tides, we're trying to be preemptive, which is very difficult to do when everything's based on weather that you experience. But we've learned that to some degree we can do that, and it just makes it a little bit more efficient. We tend to work between October and April, sometimes throughout, but we can do short hauls with 2 trucks and we can do long hauls with 7 trucks. 2003 was interesting in that it was such a cold, frosty, snowy winter. We actually did no work on the beach after the 7th of February. There was no need. There were no southwesterly storms. Conversely, in 2016, we started recycling on New Year's Day, and we carried on right the way through to Easter. And consequently, the volumes we moved changed. You know, look at these 2 consecutive winters, 2012 to 2013, we moved just over 60,000 cubic meters. The following winter, we had to move 160,000. That's a big difference. So the future, everyone who's been involved in the contract, everyone who's been involved in the contract says that it has been a very good contract. My personal view is that this type of contract is ideally suited to maintaining soft defences. You need to have some flexibility. The other thing, there needs to be a local expert who can oversee the works. It doesn't have to be someone like me working for a contractor. It could easily be, or probably even better would be, being somebody within the Environment Agency or the local councils who understands, you know, what happens in their own locality. And doing that, you can actually then develop the best solution for each of your locations. As I said, you need flexibility. In our case, financially, we get paid the same amount every month for the 25 years, and it's entirely up to us when we spend it. We don't have to hand it back if we don't use it in a particular budget year. The type of contract also gives us technical freedom, so we've been able to innovate with various things over the years and try things to see if they work, which you can't do under a normal contract. And temporal, we can do things when they're best suited to the sea defences or when we can see that they will work. We don't have to wait for next year's budget or whatever. We can just do it when it works best. And what all this does is it allows things to evolve. So we have some idea what sea levels might rise in the next 100 years, but we don't really know. Climate is changing. Is it going to continue changing at the same rate? Will it be different? We don't know. All authorities are being asked to provide more housing, so inevitably some of that housing is going to be on the coast. How are we going to cope with the coastal development? But all of this feeds into an even bigger picture, if you like. Again, this is my personal view of what I've learned over the last 20 years and working in the soft sea defence environment, is that we should really be looking at larger management units. You know, in this area, we should be looking at Eastbourne all the way through to Hastings, or possibly all the way through to Rye. When you look at the work that the Regional Beach Management Plan did, we have sufficient sediment on the coasts, but it's not all in the places where we can best use it. So should we not be looking at better ways of moving or reusing sediment on that coast and how we move it along the coast, rather than just going and dredging more seabed? We have just over 3 years to go on our contract, but the Environment Agency is already looking at a scheme whereby they're going to link Pevensey and Eastbourne from 2025. So they're looking at starting that process that I've mentioned in the first line of the slide. They're in the process of reviewing all of the options they have, and they want to look at a 100-year solution, which I think is incredibly foresighted, but actually presents its own problems. How do we know what the world's going to look like in 10 or 20 years, let alone 100 years? How do you plan with that detail for that far ahead? So I wish them good luck on that, but their preferred solution is going to have to be adaptive. It's going to be something that must take into account changes that come along in the future. You know, carbon footprints are a big thing at the moment, but how do you try and quantify what the carbon input is going to be in 10 years time? You know, the carbon that my machines generate now may not actually be there in 10 years time because we're using hydrogen engines. And quite rightly, everything is looking at using nature enhancing solutions. And a final thought for me is that I won't be doing anything after the end of this contract, but I hope that the experience and knowledge that I and my team have gained and we passed on to the agency is not lost, and it can be of use elsewhere. Thank you.
Thank you, Ian. That was excellent. That was phenomenal and took me down quite a bit of a memory lane with regard to Pevensey as well. Thanks for Okay, this is just a note for everyone. If you can keep your questions coming in for all the speakers, we'll be looking at those at the end of this discussion. Okay, we're now going to hear from Andrew Rouse, who'll be taking us through another case study, this time for Linkshore on the east coast of England. Andrew started his engineering career working for Halcrow out of their Peterborough office. Andrew specialised in river and coastal engineering around Lincolnshire and Norfolk coastlines. In 2003, he joined the Environment Agency's Anglian Regions procurement team before moving back to day-to-day engineering activities in 2007. Andrew is now the agency's programme manager on the Lincolnshire coast. So Andrew, over to you.
Thank you very much, Jonathan. The Lincolnshire coast can be summed up using 3 key words for how it has been developed and managed over time. First is going to work. Defend. The past was to hold the line, whatever the cost, whatever the environmental emissions, and whatever the impacts to the local community, whatever it takes to keep that North Sea out. To manage, the present management solution is assessed against various government appraisal documents criteria for the preferred solution. A change from flood defence to flood risk management, and more recently continued all of those technical, social, economic and environmental challenges bring in the climate and water crisis, net carbon zero, the UN SDGs and sequel. And finally, transform, future, working with the local communities and partners to look at how coastal communities can be less reliant on the defences through adaptation over time. The coast of Lincolnshire is protected by 128 kilometres of raised sea defences, including within the Humber Estuary and the Wash. These defences protect the fens from coastal plain, which lie at or below sea level and account for around 50% of the total area of the county. These areas are currently well protected from flooding, but future sea level rise could increase the risk of coastal flooding if the defences are not maintained. Some 220,000 people live in the Lincolnshire coastal zone, amounting to around 103,000 households. East Coast also contains 200 caravan sites, which equates to nearly 30,000 static caravans. We believe it's the largest concentration in Europe, with a permanent population of around 6,600 people. Their main focus is very much on tourism. Lincolnshire as a whole is the largest single contributor of agricultural production in England, providing nearly 30% of our field vegetable crops in the country from its Grade 1 arable land. The slide also shows the different environments that are found along our Lincolnshire coast. In the north and the south of the scheme, we have areas that are environmentally sensitive, that up until recently have generally looked after themselves. In the central section, in our main focus, some 22 kilometre stretch between Mablethorpe and Skegness, where majority of the frontage is protected through a concrete seawall. It is also this stretch where majority of the towns and villages have grown, and the main focus on tourism, the bucket and spade industry. Up until the 13th century, the coast of Lincolnshire is thought to have been protected by a series of offshore coastal barrier islands. During the 13th century, the sea began to make significant inroads into the land here, reclaiming a mile or more from the coastline, as the offshore barriers were damaged during storm events. By the end of the 16th century, this movement of coastline destroyed a number of low-lying coastal settlements. It was the rise of the coastal tourism during the Victorian times that saw the construction of the promenade and the low-level seawall, not to hold the sea back, but for people to be able to access the beach. On the 31st of January 1953, considerable areas along the Lincolnshire coast were flooded. Following the 1953 storm, the sea wall and its protecting measures were built that created the current alignment of today's defences. The beach is now being constrained, therefore continues to fall, exposing the seawall foundation. An extensive programme of seawall improvement took place between the 1953 and the early 1970s, but ongoing maintenance became an issue. So we had to look at a new management regime. Beach nourishment commenced in 1994, initially to build the beach up and to protect the seawall. And then post 1998, an annual nourishment campaign has been undertaken each year to sustain the beach and the protection it provides, as the business case and the design include for a loss of material around 10% for the entire beach frontage, 550,000 cube of material. Without it, the beach would be lost, leading to the likely failure of the seawall within around 7 to 10 years. Our current management regime has kept people, property, and importantly, habitat dry during a number of major coastal events, most recently in 2013 and 2017. Start of today's journey, described as one of the UK's worst natural disasters in modern time, the Great North Sea of 1953 inundated thousands of miles of coastline and left 300 square miles of land submerged underwater, ruining vast areas of valuable farmland and killed hundreds of people. This 53 event exposed the weaknesses of the East Coast Flood Defence Scheme in a dramatic and tragic manner. Following on from that, there was significant investment in the weak points and where any future problem would like to be great. On the 31st of January 1953, considerable areas along this coastline were flooded. There were 9 major breaches and over 100 smaller ones that in turn led to erosion of the rear of the defence and their collapse. The Mablethorpe, Sutton-on-Sea and Skegness areas were the most seriously affected, and 42 people lost their lives. As you can see from the video, the event caused widespread disruption, with not only seawall and sand on the main streets, but people and property badly affected. In some places, the watermarks can be seen some way up the height of the building. I do feel the interesting point is at the end of this video is that the defences look like they were purely concrete stepworks or a veneer of concrete placed on sand mounds, likely built in Victorian times with their love of walking on the frontage, promenading. They clearly were not designed as coastal defences. The solution on the Lancashire coast was to build back stronger. That included hard structures, such as concrete seawalls, revetment. There was no need to undertake an economic assessment at that time. Money was found, clean up from the major flooding event and build higher and stronger defences. It is this alignment that we are working and managing today. Jumping to the 1990s, sorry, I'm going to get back up. Not stopping. Sorry about that. The business decision in the early 1990s was to improve the new beach through nourishment. This was a big change in its management regime, bringing in sand from the licensed sources offshore and bringing material to the coast and pump ashore via a dredger. I believe at the time, this was a fairly new concept within the UK. Having a beach in front of a seawall provides an effective form of natural coastal defence, efficiently absorbing the energy of approaching waves, hence protecting the seawall structure and reducing the risk of wave overtopping and cost of any repair to the actual hard defence. Beach nourishment also acted as a blanket to the underlying clay layer, which protected it from long-term erosion. This new approach included the placement of 5.5 million metres cubed of material over several years. This option did raise the need for future annual nourishment to replace the predicted loss determined at around 10%. It is this legacy or problem that we are still managing now and would like to be managing for long term into the future. James, the sound's not working.
What we have found over the last 15 years is that it's generally come down to 7 key hotspots, as we call them. We are providing a standard of coastal protection to the local community by replacing the sand on the beach and working with nature to ensure that we not only deal with a local flood defence, but also a local tourism attraction in regard to a real valuable amenity for the local community.
Team Van Oord is faced with a number of challenges in successfully meeting the goals of its clients. For one, there is a limited working window. The sand can only be pumped onshore during high tide, and the works cannot coincide with the arrival of tourists during the summer season and bank holiday weekends. Along a stretch of 20 kilometers, there are currently 6 beaches that must be reshaped by the addition of new sand. Some 460,000 cubic meters in all, to restore the natural slope from the waterline to the bottom of the dunes.
The main reason for that is that a natural sloping beach is the best way to dissipate energy, wave action. The seawall itself will provide the standard protection, but the beach here provides a stability to the actual seawall itself.
Far too often within my organisation, this scheme is viewed as simply putting sand on the beach. But for those people in the know, we know differently. Coastal schemes are technically challenging with all the people and equipment needed to make sure that the material is of good quality, lands on the beach in the right place without incident, whilst keeping costs in line with the contract. The works are very weather dependent with tides, currents and wave generations. Recent challenges of the team are around dealing with climate crisis and looking at how we bring CEQA, UN SDGs and working towards a net carbon solution. Majority of our schemes from the Environment Agency operate during daylight hours, Monday to Friday. Coastal works, although are likely to be common to you on the call, are typically around the clock. We work tides to keep the equipment working as efficiently as we can. Coastal schemes are also working like in a goldfish bowl. Everything you do can be seen and witnessed by the general public. Now armed with those cameras and videos ability through their mobile phones, it's important to proactively engage the local community and stakeholders to keep them informed and to minimise inconvenience during the construction of this challenging scheme. The Environment Agency is aiming to be carbon neutral by 2030. This aim is embedded in the project team from the very start of the business justification of the preferred solution. The long-term nature of this project means that we can often pursue carbon-saving initiatives that are beyond standalone projects. For example, the long-term nature of this scheme has enabled us to invest in an energy-efficient site compound. Excess electrical requirements from the solar panels is transferred to the national grid, providing a small contribution to the green energy target. All of the site team use hybrid cars with charging points available on site. And as part of the Van Oord's own sustainability strategy, we've also been working with Shell UK to develop biofuels for the shipping sector. As a result of this collaboration, biofuels were successfully used in their dredger AM316 for the 2020 campaign. This is the first known incidence of the biofuel being used in a dredger within UK waters, bringing around about 45% reduction in carbon, amounting to 700 tonnes of carbon equivalent to traditional marine fuel oil. Our ambition is to be able to make key decisions based on evidence and quality held information, and to make our mistakes within a digital environment so that we can get it right first time in the real world. Our digital mindset is supporting this ambition through our 5 R's. The right information in the right format is given news to the right parties at the right time to allow them to achieve the right outcome safely and sustainably. It is these 5 R's that are the key to our success, over and above us having the correct team with the right knowledge, skills and experience. We manage data in our own respective common data environments, namely A-Site and Business Collaborator. The whole project team has embraced the application of providing better, timely data to the project for the benefits from a single truth and access to the latest data. A CDE was used to identify the project deliverables and capture improvements in held information, which were progressed through the workflow, allowing full auditability and traceability. Successful application of BIM has relied upon each member of the team applying and adhering to the requirements of the BIM process. This was ensured through training and ongoing support across the team. The BIM approach applied here is transferable to other projects and has since been successfully adopted by other Environment Agency and Van Ord sites. As part of our project, relevant asset information from the Environment Agency archives has also been digitalised and collated into a geo-referenced asset database. On-site investigations and testing has been undertaken to obtain information regarding the condition of the seawall, the majority of which has been buried since 1994, and little was known of its condition, the sort of out of sight, out of mind philosophy. This valuable information has improved our knowledge of the existing asset so that we can better understand and estimate the risk of their failure, and it will be used to inform future asset management and emergency response. One benefit from COVID, if there is such a thing, is that we all have to improve our knowledge and use of digital interfaces that will save time, cost, resources and miles traveled. The Shoreline Management Plan looks at how we can best manage the flood risk over the next 100 years. Each stretch of shoreline is different and therefore is assessed separately. The open coast section falls within the Flamber Head to Gibraltar Point Shoreline Management Plan. From the high level plan, a strategy is developed looking at options and their affordability against government funding, policy and law. Currently, the plan is to hold the line, but with the potential of costs to rise in the future, local realignment may be needed to provide that 0.5 AEP or standard of protection, the 1 in 200 chance of flooding in any 1 year. The question, how do you realign or step back a sea defence when the land behind can be up to 2 meters lower than the current foundation of the wall that you're managing and maintaining without causing a future maintenance burden on the taxpayer? The answer, we hope, will be the future. The scheme for the future is now under the Saltfleet Gibraltar Point banner and no longer a Class 2 as Linkshore. The drive is to move away from climate and carbon mitigation to climate and carbon adaptation. The need to educate, allow people to live with the understanding of the potential of the risk of flooding through resilient communities. But when the time comes for that surge event that will overtop the defences, they will need to move to higher ground for that event and maybe for their long-term future. This is a change in mindset, as most people do not understand the potential risk that they live at even though we have been trying to inform them and provide the evidence for the last 20 years through widespread consultation. Some people do just not want to listen. The slide shows the high-level values that were taken from the strategy in 2019. Since this time, several key guidance documents have been updated and revised. And for example, it'd be interesting what comes out of COP26 in a few weeks' time to look at what any new incentives are going to be put within our community. The ambition for the frontage is sort of clear. We need to work with partners. We need to work with others. We need to work with nature. We need to enhance public confidence in what we do and how we say it, and the evidence we provide to basically support that discussion. We need to also reduce environmental impacts, all leading to a local resilient community. My team are now at the stage of continuing to deliver and sustain the protection through annual campaigns, but are very much thinking and planning on how we are going to deal with the future. There is no point building a defence higher, bigger, gold-plated, only that the businesses behind are not sustainable. It is about growing together. To achieve some of that, we are looking at a blueprint. This slide shows some of the thinking of our blueprint, a roadmap to success. We have given ourselves time to engage and consult with others prior to the business case to ask Treasury for major investment. The only question that we are asking ourselves is, will Mother Nature give us this time? As many will state that we are due another major coastal event or surge very soon. If you refer to the increasing high risk levels and frequency of events we've incurred over the last 10, 20 years. I trust today's presentation has given you insight to the challenge and changing times and management of the Lincolnshire coast, a scheme that I personally have been involved with since 1997, and I've undertaken several different roles along this frontage, from designer to contracts manager to procurement, and now I'm very much leading it as the programme manager. We have been given this opportunity at a critical time within our history, not only to manage the challenges, but we are given hope to provide the next generation with a better place. Based on our legacy of doing the right project and adapting to the climate and the water crisis, while changing people's behaviour through education and knowledge, so they can live within a resilient community and not be reliant on just building our coastal defences higher and higher. To me, this is a very exciting time for us all. Thank you.
Okay, thank you, Andrew. That was excellent. That was, yeah, really informative. And now we're going to move on to our Q&A session and discussion. So if I can invite everybody to turn on their webcams and microphones, and hopefully it won't completely kill the bandwidth, but we can but try. Okay, so we've had quite a few questions come in from the audience. So what I'm going to do is I'll pass them on and try and allocate it to specific people, but then invite the wider panel to just chip in as and when they want to. Okay, so let's see how we go. Okay, so the first one we're going to look at is relating to local community. Okay, so there's basically a couple branches here. So this is specifically to Carl initially, but then again I'll invite the wider panel to discuss. So Carl, overall, how did the local community respond to the Russell scheme, and also how can we better cooperate with coastal communities?
Okay, that's a great question. The Russell scheme was adopted and owned by the local community. It's just a scheme which is loved by them, and that's what we really need to recall is this is quite a deprived community, and their access to free activities and recreational activities is crucial to that community. We worked really hard with them in terms of telling them what we were doing. We were going to be disruptive to them. We brought in, as I said, 500,000 tons of rock by road past their houses, but we got very few complaints, and they were involved all the way through in what they wanted. And the key things were access and being able to just walk and cycle and have safe areas, and it was crucial to them and to us, and it's really is well used, and that's the key. And really good high quality materials, and it's turned an area that's that was really run down, to be fair. There was the defences that were in a really bad state, and it's turned it into a nice area where people actually come to visit. So that was the first part of the question, and then the second part was around how do you get communities involved. I think that's having a common basis and understanding of the problem, and involving them in the solutions. It was relatively easy for us because you could see what the problem was, and they'd been flooded before, so they understood what the issues were. But it was taking them along that journey and telling them what's happening. So part of the Coast Watch, as I mentioned, was trying to get them to understand the data that we're collecting and answer their questions. So why were the beaches moving? Why were bars forming off the beach? Why were we getting channels and various things? And trying to explain to them in an easy way that they understood at various different levels, and they could get involved with that and actually play a part in being part of that data set, so that we use their photographs and various things to embellish the data that we're collecting. So we can use they're basically observations to give us more information and feed that back to them. So it's that involvement side of things. Quite a long way to that side.
Thanks, Carl. Ian, do you fancy chipping in on this one?
I've got not a lot to add to that, really. I think in our case, because we're here for the full 25 years, that made communication a lot easier. We instigated an open door policy straight away. And I think, as Carl alluded to, you have to provide information at the correct level for the person asking it. So if you're getting universities and academics, you know, they'll be looking for level differently to Mrs. Miggins, who lives down the road. And I think, you know, from my point of view, it was, say, having the open door policy. So you give somebody some information, they can absorb that information, go away, think about it. Okay, I didn't really understand that, but they can come back and get some more information. So it's that continuous process, really.
Thank you. Andrew, and over to you. Is anything you want to add?
Well, I think it's just key, as you say, about getting the right evidence and the right information out. I mean, from our consultation input, we have some that remember the 1953 floods. They have given us a massive amount of information from their knowledge and their stories and what actually happened. And to be honest, they are the most supportive people to whatever we do going forward. But then because we have been there for a long time. I mean, I'd say 94 was the sort of main start putting the beach in. The new people who arrived since then don't understand the risks, don't understand really what threats they're at. And we've engaged fully with them, but they need to want to be able to hear us, not actually always understand how we move forward. And I think that's going to be our biggest challenge. And I might need to, you know, get some support from others on it of how we've managed to tackle that in other parts of the country, because actually getting that community spirit and that community understanding is going to be vital, whatever we do in the future.
Okay, thanks. Alan, last but not least, anything from your side?
Just obviously I talked about the Poole Bay Beach Management Scheme. We do a lot of work each time we have a phase on site with lots of warming up several months in advance to communicate what we're doing, why we're doing. We've got dedicated email for people to ask questions of, and we try to respond in a timely way using social media as well. But yeah, agree, communicating what we're doing and just being on hand to answer questions and concerns is just really important part of what we do.
Great, thank you. Just so that everybody knows, we've got an awful lot of questions coming in now. So if we don't, and we're not going to get around to answering them all now, but we will. The panel will be answering them, and we'll be sharing that after the meeting. But if I do the next one, which is fired at Ian initially, which is sustainability is key to beach management. How does the panel think things will evolve to reduce the use of carbon in the future?
Oh, thank you for that, Jonathan. That's really kind of you. As I said in my presentation at the very end, I think this is the most difficult thing to plan for, especially if you're looking at longer term solutions. You know, we generate somewhere like 800 to 1,000 tons of carbon a year just from using machines on the beach. But we've had an electric bulldozer on the beach. Okay, at the moment they're not as good as their diesel counterparts, but these things are moving on. Technology is moving on very quickly. As I said, I don't think it'll be that long before we have hydrogen engines. Then the whole balance changes, because you can probably then do beach maintenance in the way that we're doing it without a massive carbon footprint. But so I don't really know how you're going to plan for that in the future.
Okay. Anybody else like to chip in there? I'll open the floor.
Shall I chip in there before Carl jumps in? I think at the moment we're doing a lot of great work around carbon mitigation, and I think technology is helping with that, with new equipment, new plant, and I'd say very much around the sort of the biofuel area for the use in marine, and even to the point of, I hate to say gas at the current time, but gas dredgers are coming online. There's a new sort of technology, but the real measure here is the future adaptation. How do we move away from that reliant coastline and really change people's minds? We seem to be stuck with the legacy of the Victorians and their love of the beach. And at some point, the business, and I'd say the UK business, is going to have to say which areas we protect and which ones we don't. And this should be done at a high level. It should be project by project necessarily, in my view. It should be done from a UK point of view. So those projects that can achieve even net biodiversity gain and carbon mitigation and carbon adaptation can really help those others that it's more complicated and challenging to do so.
Thank you, Andrew. Carl?
Yeah, okay, I'll be very quick. I think technology is one side of it. The other side of it is how we value carbon, and carbon's going to become, it should be almost as important as the monetary side of things. So you can put more money in, but and reduce the carbon, but at the moment that doesn't quite work in the funding of schemes, but I think that's going to come forward. The other side, as Andrew said, is the adaptation and understanding your coastline better, so you only do interventions when it's necessary, and reducing the number of interventions is possibly the way forward to reduce that carbon and to work with nature a little bit more. So we're looking at how you can sequester carbon in things like sand dunes and salt grasses and various things like that. So that's the future.
Okay, thank you, Carl. Alan, anything to add to the panel?
No, I think, yeah, immediate term, probably technology is going to be a key way of reducing the carbon footprint, especially if we're going further afield with our dredgers to get the sediment we need. I agree with Carl actually that how carbon drives the appraisal process and thinking about whole life carbon and what that does to selection of preferred options will be interesting. I haven't seen anything particularly coming through about how the carbon is going to influence on a parity with the other factors we go through in the appraisal guidance. So it'll be interesting to see what that looks like in the coming years.
Okay. Thank you, Alan. Okay, and I think we'll do this as our last question because we're running out of time. This is specifically to Alan initially, but we'll widen it up afterwards. So if local sand supply was a challenge for the PBBMS, how likely is this to be an issue on a national level if beach management is the preferred approach?
That is a good question. I think it will be a challenge in certain places. It's going to depend on the dynamics of the system where you're currently getting your sediment from. If we're relying on licensed dredged areas, we're competing for that material for beach nourishment with construction industry. So if it's been taken out of a system entirely to be used for building works, that's not going to be a replenishable source. So that has to be understood. I think, as far as I'm aware, there hasn't been a comprehensive national study looking at future recharge needs and sources. I think the last one was done, I think it was a CIRIA report around the time of the 96 first edition beach management manual. And I think that would be a useful exercise to undertake, actually, to revisit where will I manage beaches? What sediment are they expecting and requiring longer term, and where's that going to come from?
Thanks, Alan. Andrew, Carl, Ian, anything to add there?
We don't have any sand.
Not on the upper beach, anyway.
Well, we don't import sand.
You know, building on what Alan said, I think it has to be an industry-led element here, and of course it's going to be consultation with the MMO and the Crown Estate. I think they have a big part to play to support us in trying to keep UK dry, if we can, in regard to our flood risk management of our coast.
Yeah, my only point on that is the flexibility in moving sediment around the coast, because we've got lots of sediment where we don't want it, and a lack of sediment where we do need it, and at the moment that's a difficult thing to achieve. And
yeah, I think that's a very good point. That's the sort of thing I was alluding to, is that how do we get material? But I think you know, that your point, Carl, as well, is that it's not that easy to do, because you've got to get a license to do it.
yeah, exactly, and that puts off most. Yeah, it makes it almost impossible, and I think that's it's that flexibility to do things which I think we need to develop.
I think that's what I was sort of alluding to a little bit with the MMO and the Crown Estate, because they're ultimately going to provide those licenses and those assurances, and that's linked to other key stakeholders and RMAs ultimately. I mean, Natural England have a big say on how we can do work and not do work, and you know, rightly so. But there is an element here that we do need that flexibility of time, or you know, time of year, and how we do work to really drive that, reduce carbon, but also reduce cost.
And I think for me, it's that collaborative working to a joint objective. So yeah, that's where we need to be. So it's I don't know how we do that. It's something I'm trying to do through the Innovative Fund, the resilience bid, but it's yeah, it'd be an interesting one for the future. We need to do it so that we work for the same outcomes and work more flexibly.
Thank you all. Sorry, I kept butting in there. Alan, Carl, Ian, Andrew, thanks for your valuable contributions today. It's been excellent, actually, and I hope that everybody on the call here has found the day informative and enjoyed the discussion. We've heard from activities from all around the coast of England, which has been excellent. So thanks to everybody who's actually joined this. We'll be circulating a link to the speakers' presentations, provided we've got their consent, and we'll also endeavour to respond to any of the questions that have not been covered today, and there is quite a few of them. If you've got any additional questions, please contact the CIRIA team. Finally, we are keen to hear about your webinar experience today, and would be grateful if you could complete the online survey, which will be emailed to you shortly. Thank you.
And thank you, Jonathan, and thank you, speakers, as well. And I just want to reiterate that it's been great. I mean, we had a really good turnout, around 90 attendees today, and that just puts it in perspective. I think people were really pleased to see some superb case studies, and also just fascinating to see the impact of the beach management that you have put in practice. And it's really good to hear the mantra like hold, manage, and transform. And I think you spoke for everyone there, Andrew. I think it's really important to see the various issues, whether it's supply or whether it's delays or climate change. But more importantly, it's great to re-emphasize the options that you've got available nowadays. A lot more than just timber. You've got precast concrete, you've got the rock solutions you went for. And also it's fueled, isn't it, by the availability of data, spatial data, climate change data. We're in a much better place. And I was interested to hear that there might be scope for a follow-up guide or guidance in the future to take this further, to take the legacy that Jonathan and others have put together. And maybe also, like it was highlighted in some of the case studies, the emphasis on local expertise and local engagement with the local community. That's becoming more and more important. So thanks again to the authors and the speakers. Just want to flag up, obviously, the next webinars in our 60th anniversary series. So we've got the Rock Behaviour Manual and Hydraulic Engineering, 23rd of November, one for your diaries, as well as the International Levee Handbook, looking at the impact of levees on flood risk management, coming up on the 8th of December. And also, I wanted to flag up the fact that we recently started, with the help of the Environment Agency and other members, our work on the integration of non-flood defence strategies into the flood defence system, which the agency obviously is responsible for, trying to bring together third-party asset owners from maintenance all the way to whole life cycle in this regard. So if anyone wants to contribute to that, do get in touch with us. And I just want to finish on the note of saying thanks to everyone who was involved, thanks to the audience for the questions, and like Jonathan said, we'll pick up questions later if they weren't answered. So thanks again, and I hope to see you at the next webinar. Thank you.